Well, I hope you enjoyed those clips. In coming back to the chapter, healthcare-associated infections are any infection that is acquired in a healthcare setting. We also call them nosocomial infections. We can prevent a lot of these. 3 factors contribute to nosocomial infections. 2 of them we can't help. Patients in hospitals are, by definition, compromised. They are sick, they are injured, and their immune systems aren't at its best. Microbes are going to be in the hospital environment. Patients bring them in, especially if they're in the hospital because of an infectious illness. What we can change is the chain of transmission. We can work to prevent microbes from getting from the infectious patients to the other patients and staff. Part of breaking the chain of transmission is the universal blood precautions. I have here links to the actual documents on the web, and the textbook goes over them very well. Understanding and following universal blood precautions is vital to anyone going into a clinical career. Also, as a patient, you may want to help remind your care providers. Well, if you can. Okay, last topic. To fight various diseases, we need to know what causes them. We are able to figure out the causative agent of some diseases by using Koch's postulates. Koch was a contemporary of Louis Pasteur, and he was the first to prove that a bacterium caused a specific disease, namely that Bacillus anthracis caused anthrax in farm animals. He took blood from a sick animal and isolated the bacteria from the blood. When he looked at them under the microscope, he could see that they were large gram-positive bacilli. Koch then inoculated the cultured organism into another animal that was not showing signs and symptoms of the disease. The animal then developed the signs and symptoms of the disease anthrax. Koch was able to isolate the same large gram-positive bacilli from the second animal. Koch never found the large gram-positive bacilli, Bacillus anthracis, in animals that were healthy. We still use his steps when we can. There are some diseases that are fairly straightforward. For example, we can show that adenovirus causes colds. We isolate the virus from people with colds, we inoculate healthy volunteers with the virus, and sure enough, they develop colds. We never isolate adenovirus from healthy individuals. But for some diseases, we can't do this. For AIDS, for example, we don't have an animal model that we can use, and it wouldn't be ethical to inoculate humans with a pathogen that may cause a lethal disease. We have had to modify Koch's postulates to prove, unquote, that HIV causes AIDS. We don't find the virus in healthy individuals. We always find HIV in patients that have progressed to AIDS. Numbers of HIV virus that can be detected in the blood is a good indicator of how well the patient is doing or is going to be doing. Periodontal disease is another one that we've had to modify Koch's postulates for. We find the same bacterial species in healthy mouths versus those with periodontal disease. We just find them in different numbers. In health, certain bacterial species are found in small numbers. In disease, they have taken over. Oh, that was a long one. But hopefully it was interesting. We are finally getting to what you took this class for. Before we end this video, let's do a quick reminder of what I want you to get out of this recorded lecture. I want you to be able to differentiate between pathogenicity and virulence, define opportunism, list the steps a microbe has to take to get to the point where it can cause disease, list several portals of entry, define infectious dose, describe 3 ways microbes cause tissue damage, differentiate between endotoxins and exotoxins, provide a definition of virulence factors, draw a diagram of the stages of disease in a human, list several different modes of transmission of infectious agents, define healthcare-associated infection, and list the 3 most common types. List Koch's postulates and when they might not be appropriate in establishing causation.